Good morning, good afternoon, everyone. Thank you for registering and attending Think 2020 Digital Conference. We are beginning the masterclass deep dive into Istio session 6829 now. Please meet our speakers, Lin Sun and Ram Venom.
Hi, good morning, everyone, or good afternoon if you're in Eastern time zone like us. My name is Lin Sun. I'm a senior technical staff member with IBM. I'm also an Istio maintainer, being on the project for almost 3 years. I also serve on the steering committee and technical oversight committee for Istio. Ram?
Yes. Hi, my name is Ram Venom. I'm one of the technical product managers, offering managers on our IBM Cloud Kubernetes service and Red Hat OpenShift on IBM Cloud Services. But I focus mostly on service mesh, so things like, I focus on Istio. I'm also on the Istio steering committee. I've been on the Istio project for a little over a year, but I've been doing containers and Kubernetes since they first started about 5 years ago.
That's great. In case you guys don't know, IBM is a member and also a co-founder of the Istio open source project. Today, we're going to take you guys through a deep dive of Istio. Mainly use the book we recently wrote, Istio Explained. I actually have a copy of the book with me right now. So managing microservices, as user moving from monolithic to microservices, you will probably find out microservices can be complicated and difficult to manage. The increased use of containers and cloud has really expanded the distributed nature of your applications, and that further complicated development and operator team to understand and control the interaction with microservices. I would imagine you probably seen some challenges if you're on the cloud native journey with microservices. For example, how you can observe the interaction between your microservices when you have many distributed and loosely coupled components. How do you do traffic management of each of your service endpoints to be able to enable specialized routing, whether you want to do A/B testing or whether you want to do canary testing? How do you do secure communication of your microservices? And how do you manage that timeout and even communication failure among your microservices? Service mesh is really targeted to help you solve this problem so that managing microservices doesn't need to be complicated for you. What exactly is a service mesh? A service mesh is a programmable framework that allows you to observe, secure, and connect microservices. What's most importantly of service mesh is service mesh provides this framework for you to help you with these functions so you don't have to build in these functions within your microservices. How do we actually get here? Let's start with talking about some of the histories. Some of you might already know Netflix OSS, might even use Netflix OSS at one point. So Netflix OSS stands for open source software. It provides Netflix OSS libraries. It works really well if you are developing Java applications, and also if you are willing to adjust your application code to work with the Netflix OSS libraries. But that immediately raised the concern of what if I'm actually dealing with many languages? What if I don't want to adjust my application and I don't want to rebuild my container image to pick up the latest Netflix OSS libraries? The rise of Kubernetes, as many of you guys seen, Kubernetes has become the standard de facto container orchestration system. Kubernetes has made it simple for users to develop applications using containers with multiple languages. So that combine of Netflix OSS and the rise of Kubernetes really kind of made the industry rise up with modern service mesh system, which is what we now call service mesh. Let's talk about some of the common service mesh functions that would be provided by the mesh. Traffic shaping with dynamic controls between your services. This will be useful when you have multiple versions of your services. You're going to need to be able to dynamically control the traffic shifting. Be able to have resilience among your microservices so you can configure circuit breaker and timeout and retries. And most importantly, you don't have to build that logic in your application. Be able to observe the traffic among your services, be able to analyze where you spend the times on each of your services, be able to precisely trace the communication flow for every single request. And most importantly, I think this is actually the most important feature that we see a lot of users being forced to adapt to service mesh because they need to secure communication of their services, and because their security team asks them to have that checkbox. How does service mesh really work? A common service mesh, we look at through multiple service mesh vendors. They typically have a service mesh control plane where users will be interact with the service mesh control plane to be able to program that proxy. On the application layer, the app 1 and app 2, they're not going to talk directly to each other like the traditional way. Instead, the traffic would be controlled by the sidecar proxy that runs alongside of the application container. So by having the communication routed between the proxies is a key control point for performing complicated tasks such as TLS handshake for encrypted traffic. And most importantly, there's no need to actually embed that complicated networking logic, the complicated tracing logic, the complicated TLS handshake logic within your application container. Let's talk about some of the service mesh ecosystem. As part of writing the book, we actually evaluated a bunch of service mesh ecosystem out there, and some of the key criteria as part of the evaluation were focused on whether the project has been donated to a foundation, whether the project has diverse contribution from the community, and how successful the project is adopted by the users. So Envoy is certainly a leader in this space. Envoy was created by Lyft, and it's one of the few graduated projects in CNCF. There's not many projects being graduated. Last time I checked, there's only like 6 or 7 projects. Envoy really have a diverse community where Lyft, even though it created Envoy in the first place, it's no longer the #1 contributor in the Envoy community. I believe they're #2 right now. Istio is a project founded by IBM, Google, and Lyft about 3 years ago. In 2017. Istio has many other key players in the community. Last time we checked, I think it has contribution from 300 companies, including VMware, Huawei, Alibaba, Salesforce, and many other players out there. The diverse community of Istio is very well recognized. Console Connect was developed by HashiCorp, It extends existing console offering. It's currently not in a foundation, and it also uses Envoy as a sidecar proxy, same as Istio. Linkd is from Buoyant. It has its own sidecar proxy written in Rust. Notice Linkd is the only service mesh vendor that actually has its own sidecar proxy. The primary contributor for Linkd is Buoyant, and it focuses on simple to use for Kubernetes environments. AppMesh is a cloud service hosted by AWS to provide service mesh for compute systems within AWS. It's kind of proprietary. It's not using any of the open source we mentioned here other than use Envoy as their sidecar proxy. Kong Service Mesh, it builds upon Kong Edge capabilities for managing APIs. It also uses Envoy proxy, and it's not currently in a foundation right now. Aspen Mesh is a really interesting scenario. They build on top of Istio by hardening and offering support through a paid offering. So it's exciting to see vendors like Aspen Mesh be able to offer a supported offering around Istio. Last but not the least, service mesh interface. It attempts to be a common interface for service mesh implementations. While the concept is interesting, it's actually pretty hard to grasp and actually realize in reality with the service mesh ecosystem moves so fast and the vendors having differences in functionalities. It's harder to build that common interface, and that's the functionality becomes really boring, and it works consistently among all the vendors. Let's talk about Istio, not only because we are the founder of the project, but also we like the rich functionality of Istio. We start to see Istio simplifying many of the fronts also to really help users to adapt Istio. At the heart of Istio is really three functions for microservices. It allows you to easily connect to your microservices, allows you to build secure communication of your microservices, and finally allow you to observe really what's going on within your microservices. And most importantly, it still delivers these functions to user without you need to modify your application code, or really with very minimum modification, little or zero application code change. Istio architecture. So Istio control plane is really at the bottom of the layer. The community recently, in the most recent release of Istio 1.5, have consolidated all the control plane components into one single component called Istio-D. This really helps the operators and of the mesh to be able to easily deploy, to be able to easily manage the control plane components. So the Istio control plane components, Pilot, Galley, and Citadel, and Sidecar Injector, you're no longer going to see them as one thing. You're no longer going to see them as individual deployments and individual services. You're going to see them as one single component, but the functionality is the same. Istio-D really in charge of discovery, configuration, and also mints the certificate for the sidecar proxy. So an easy way to think about this is users can configure Istio through Istio resources by interacting with the Istio control plane, and then Istio control plane to help user to distribute that configuration to program the Envoy sidecar to be intelligent. The data plane is really the user's workload from their services along with the sidecar proxy running alongside with their service container. Further, the user can control the edge traffic through the Istio Ingress Gateway to control exactly what services are exposed to be outside of the mesh, and also help user to control what services can reach which services from outside of the mesh by using an egress gateway. So we're going to spend some time to talk about different components of Istio, from installation to adoption strategies, and also some of the Istio API. Then we're going to take through the latest of Istio 1.5 and some of the roadmap items. And we're also going to show you an interesting demo of using the applications that described in the book. Let's talk about how Istio allows users to simplify setup and management. In order to play with Istio, the first thing you have to do is kind of install it. The community has really spent a lot of time to make sure the installation is simple with one single command. So the design principle of Istio, not only from install perspective, but from everything, is also focused on, simple things should be easy and straightforward, and customization and complicated things should be possible. As you can see, Istio Manifest Apply can allow you to apply different profiles with one single command. You can switch between other profiles as well. For example, if you start with demo, you could do that, or there's other profile for multi-cluster. You can also check out the versions of whether it's the Istio Kado commands, whether it's your operator on the server side. So all that versions commands are easily available for upgrade purposes. One single command to allow you to do upgrades through Istio Kado as well. So that would help you as you decided to move from, for example, from 1.4 to 1.5. IBM Cloud provides Managed Istio. The intention is really help you to simplify setup and management of Istio. You can click on one button to install Managed Istio to your IBM Kubernetes cluster, and it's going to show you, like prompt you with the requirement of your cluster has to have 3 worker nodes. It has to have at least this much CPU and memory, and a Kubernetes version of 1.16. Then you can click on the install button to install. I would say the value of the cloud managed Istio is not just the install. I think install is actually not the hardest portion. The difficult portion is to manage to be able to stay up with the native security fixes, to be able to have automatically moving between Istio 1.4.0 to Istio 1.4.7, which includes multiple security patches. I would like to introduce you our applications that we use in the book. As you can see, the GitHub URL is at the bottom. We have kind of divided the application into 2 namespaces. So the DB2 service runs in stock trade data namespace, and the stock trader namespace has 3 services. The trade service is more responsible for the user interface, where the user can go into a browser to perform the trading functionality, to be able to see how much money they have, be able to trade stocks. The portfolio services are focusing on generating the contents of the portfolio for each user to see what are their holdings, how many stocks of different stocks they have as part of their portfolio. So the portfolio service does interact with the DB2 services because the service record, how many stocks of, for example, IBM a user has. The stock quote service is the service that actually interacts with external stock service to be able to find out what is the current price for a given stock like IBM today. You can deploy the application into Kubernetes by using kubectl commands. So this is what you would have to do before you even, introduce service mesh. For example, you can deploy the stateful sets, whether you use kubectl or Helm. In this case, we're using kubectl to view. These are the DB2 stateful sets of pods and services that made up of the stateful sets. Let's go ahead and also deploy the application trader portfolio and stock quote services in the stock trader namespace. As you can see right now, each of my pods only have like one container. So there's no sidecar being injected. And as you can see, the trade service is the one that's being exposed to as a node port service. So that means as a user, I can actually access the trade service. So this will be the resulting UI if I find out the worker's IP and access the trade service through the node ports associated. So let's talk about the first common adoption practice is to adopt the mesh just for the gateway. So notice in this case, the service A, service B, in our example would be trade, a portfolio, and stock quote service. It doesn't run with the sidecar. But what's the value for this? This would immediately provide the value of be able to control inbound and outbound traffic, be able to control routing. If you actually have multiple versions of service A, you can control that routing at the ingress gateway, be able to secure inbound and outbound traffic coming through your application, and be able to also gain the observability at the gateway as well. So let's go ahead and secure the inbound traffic. As part of the IBM Cloud, we provide a network load balancer, which contains the host and also the secure, the host name and also the key and search associated with the host name. As you can see, as a user, a common practice will be wire up the ingress gateway with the network load balancer provided for the Kubernetes cluster. So in this example, we would create an NLB host name, and it would connect when the traffic goes to the NLB host name. It would redirect the traffic to the Istio ingress load balancer IP. And you can also leverage the credential based on the key and search from the NLB hostname. So that's really the value to use the NLB hostname. So in this example, we're creating the secret based on the key and the search from the NLB hostname, and then so that we can leverage the trade credential that we created earlier, use that as part of the gateway resource configuration. So we're creating a trade gateway. You might be wondering what the gateway resource is. So the gateway resources really help user to configure the the edge configuration you can do the edge configuration at layer 3 or layer 4. You can also do it at layer 7. And in this case, we're configuring for port 443. The traffic comes to HTTPS at port 443. We want to be able to secure that using the trade credential. That's the secret we created earlier. And let's deploy that trade gateway so that it can be effective. Certainly, once the traffic reach out to the gateway on 443, it needs the virtual service resource. You can really think virtual service resources to help you to do traffic routing, to be able to route the traffic whenever it hits on /trade. It routes the traffic to trader service that's on port 9080. So in this case, it would help you, you can see when I visit my NLB hostname and when I visit on /trade, it would actually direct the traffic through the NLB to the Istio Ingress gateway, then through to my trade service so that I can see the login page. Now you can see I'm actually secure my traffic at the edge now. With prior, I was just viewing the trade application through no port. The second common adoption approach is focused on being able to observe what's going on within your microservices. You can incrementally add services to your mesh, and as the services are added to your mesh, you will automatically gain visibility of the interaction between your services. In order to add the sidecar to your pod, by deploying the pod and services into the mesh, there are a couple of requirements. We want to make sure you actually go through these requirements by adding a named service port for each of your services. So for instance, in this example, for the trade service, you can see we actually added a name port for HTTP and HTTPS. And also, each pod must have a service associated. So if your application is just doing a job without a service, that's not allowed to onboarding your services to the mesh today. You also have to label your deployments with app and version. So for instance, in this example, we're labeling trade version 2 with the app and version. We're also adding an annotation for permissions scraping to enable permission scraping. So this is really for telemetry information to make sure we can actually differentiate for you. These are the traces for this particular app for trader, and it's also for version 2 of the trader service. Also, we don't want you to use 1337 UID because the Envoy proxy are using it. And the key question to ask for whoever is deployed the service is, do you have let admin privileges? For the Istio sidecar to work, there is an init container that runs before the Envoy sidecar, which set up the IP tables within the network namespace. So it does require net admin privileges to be able to ensure all the traffic goes to the Envoy sidecar first when the traffic comes in. And it also ensures when the traffic goes out, it also goes out to the Envoy sidecar proxy. So the sidecar proxy can have full control of that traffic. Let's see how you can quickly add in services to the mesh. Istio provide a convenient command where you can add services to the mesh called add to mesh command. So that would easily enable your services to have the sidecar injected. For new services, you can also leverage automatic sidecar injection by label your namespace with Istio injection enabled. You can also enable this on a pod and service basis if you're not feeling comfortable to enable at a namespace wide. Now you can confirm, in this case, our pods are actually running. And the most important is see that 2/2 there. So it means not only it runs with the portfolio container, but within that same pod, it also runs the Envoy proxy sidecar. Now, you can actually observe the traffic communication with no change. So if we actually generate some load to the trade application, you can instantly see the application graph to visualize the traffic instantly with Kayali. So for instance, you can see in this case, the traffic will travel through Istio Ingress Gateway, and we have config auto mutual TLS, so you can see it's actually secure communication between Istio Ingress Gateway to the trade service, to the portfolio service, and to the stroke code service, which also reach out to the outside of the mesh for through a pass-through cluster to the external service that provides real-time stock price. In addition to visualize your services, you can also observe trace span for each of your requests. By launching the JGA dashboard, you can click on every single request that's been captured and then drill down to each of the requests to see the trace span among your services. So a couple of caveats here. The trace sampling by default in the default profile is 1%, which means only 1% of the traces are captured. So if you're actually doing this for testing, it will be helpful to actually enable that trace sampling to be 100. So that means all the traces will be captured for you. So you wouldn't be surprised why is your trace not showing up in JGA. Trace span can be extremely useful to analyze where the time is spent. You can use it to compile the times for base and canary deployment. You can easily spot when things go wrong, what is the connection issue, what are the error codes. It can be extremely useful to monitor retry and timeout and kind of tweak the right value for retry and timeout for you. One thing that I had to make a change to the portfolio service is to propagate the trace headers. So if your services doesn't automatically propagate the trace headers, it still does have a requirement to have all the traces span to be connected to a single request. So if you don't do this, you will get the trace span. However, the trace span are not connected to a single request. So by propagating the headers, you will help Istio to be able to propagate the key trace span headers. So Istio would know these trace spans are part of a single request. So you can see it's a small change. It's basically on the invoke the rest request path, just making sure you are copying the headers from the request and pass it on. Let's talk about our third adoption approach, which is secure meshes. You can, as we talk about, you can incrementally adding services to the mesh. You can incrementally set secure communications for one or two of your services. You can have auto mutual TLS to set client secure settings based on the target service, which, by the way, auto mutual TLS is enabled by default in 1.5 release because it really helps our user to adopt Istio security. In traditional apps, we often see communication to services is only secured at the edge. That's often the first line of the defense, and oftentimes the only line of defense is the edge of the network prior to getting into the application. So once the traffic goes through the edge, the applications may not be secured at all. Istio is aimed to provide security in depth to ensure an application can be secured even on an untrusted network. So we don't trust anything. We're going to check use secure naming information on the client side of a server invocation to determine if the client is allowed to call the server-side service. On the server side, the server is able to determine how the client can access and what information can be accessed based on the authorization policy. Istio using SPIFFE as the secure identity. As you can see, the SPIFFE examples out there. In case you're not familiar with SPIFFE, it stands for Secure Production Identity Framework for Everyone. As you can see, the SPIFFE format has namespace and also service account information as part of the SPIFFE identity. By default, Istio uses permissive mutual TLS. It improves mutual TLS onboarding experience. What does permissive mean? Permissive means when service A tries to talk to service B, the sidecar proxy will attempt mutual TLS connection first. However, if mutual TLS connection failed, it will attempt to use plain text so that the traffic can still flow through. You can continue to onboarding your services, observe your application still function. So this is tremendously helpful for onboarding. However, it doesn't help if your security team wants to mandate every single communication among your service have to be mutual TLS. So welcome to pure authentication policy. One of the most common Istio authentication policy allows you to specify, I want strict mutual TLS for a given, you can configure it for a given namespace, or you can configure it globally for everything inside of the mesh, or you can configure it to be a specific service. In this example, we are configured on a namespace level, so it would secure everything deployed within that stock trader namespace. It has to be mutual TLS strictly enforced. In addition to mutual TLS authentication policy, you can also configure end-user authentication policy by using request authentication policy. In this example, we specify the job token that's issued by secure.istio.io of testing, and it has to present, the job token has to present when accessing the Istio ingress gateway. In addition to authentication policy, you can also specify authorization policy to further tighten up the role access control among the services. For example, in this case we are typing up our product page service to the detail service, that the product page service can only issue get commands on the detail service. So any other commands beyond get is not going to be allowed. Traffic management is also a common adoption approach, and traffic management is mostly used for when you have multiple versions that you need to route traffic among different versions. Also commonly, even with one version, you may need to add resilience to your services through circuit breaker, timeout, and retries. So, so we do recommend you to look at traffic management as well. And in this example, we kind of look at Rust because traffic management has very rich API. It does take time to understand the traffic management API to precisely program the API to do what you want to configure that sidecar proxy to be. Let's talk about Istio network resources. I think in some of the early approach in the secure the edge approach, we talk about gateway. Gateway is really edge load balancer configuration. It helps you to control the traffic comes into your mesh. You can control what are the ports you want to expose, what are the protocols associated with the port number. You can also configure secure communication of your gateway, whether it's one-way TLS or mutual TLS of your gateway. Virtual service, the most easy way to think about virtual service is think about it as a list of route rules that you precisely configure how you want your traffic to be routed to. Destination rule happens when the route decision has already been determined. What are the policies that can be applied to a destination? Service entry is needed when you need to access external services from the services within the mesh. Sidecar scope is very helpful if you have many services and you don't want every single configuration be propagated to every single service sidecar. So through sidecar scope, you can precisely configure this particular configuration. I'm going to only restrict to my stock trader namespace because it's only relevant for that trade application. This is a useful diagram from route to cloud. What we like about this diagram is it kind of introduces gateway, virtual service, and destination rule precisely how it helps to control the traffic. So the gateway, as we mentioned, it would determine what are the URL being listed, what are the hosts, what are the port number, what are the protocols. And then the virtual service is the route rule to determine where the traffic was sent to. For example, in this case, it's service A for version 1 of service A. And then the destination rule, it happens when service A version 1 already been decided, and what are the policy and rules applied to the given destination. In this case, will be circuit breaking to access service A and version 1. I have to say, you know, the line between virtual service and destination rules sometimes can be confusing. So it's good to always try to find an example or look at the API repo for the virtual service and destination rule API references. Sometimes, even for me, like timeout and retries, sometimes you have to think, I already made my routing decision. Where does the timeout or retry belongs to? You may be surprised it's actually in virtual service instead of a destination rule. That's why it's always helpful to look at some of the example and refer to the API to be sure. Control traffic dock launching. So as we develop the stock trade application, we have decided, we're not going to stop at version 1. So we went ahead and developed version 2 of the application just for the user interface side. So in this example, you can see, we deploy trade version 2, but we don't want to impact our user, and we want everything to be continued routed to version 1. Notice when we're dock launching version 2 here, and most interestingly, I'm actually not modify the version 1 application. This would not be possible without Istio virtual service route rule in this case, because of I'm just deploying my trade version 2 with Kubernetes. Kubernetes will round robin between version 1 or version 2, so I could easily introduce version 2 to our user without testing. So that would be really, really fast. Destination rule, in addition to virtual service, a destination rule in this example, it just specifies subsets in this example, so that it specifies version 1 with label version 1, it's associated with subset version 1, and then label version 2 is associated with subset v2, so that as a user from the virtual service resource, the 100 weight is applied to the subset V1. You might want to selectively route requests. As we introduce version 2, we have determined, we're going to take a shot with Firefox as the agent of the user. So when the traffic goes to Firefox, through Firefox browser, we want to test the version 2, make sure it's good before we introduce to all the other browsers. So in this example, as you can see, we have a simple virtual service applied for this precisely purpose. And notice we're not changing my application, we're not redeploying of my services, either version 1 or version 2 to enable this change. As we get more comfortable with version 2, we started to do canary testing of version 2. We started to say, what, I want to route 20% of the traffic goes to version 2, and the rest of the traffic, 80%, continue goes to version 1. So I can do canary testing. Resilience testing sometimes is also useful. As user wants to tweak that retries between services. In this example, we enable retries to be 0. That happens when you are super confident your service never fail, but you could also tweak to retries to be slightly either 1 or 2 or 3, whatever the numbers you feel the best for your services. As you can see in this example, we are tweaking the retries, and also we're tweaking the per try timeout and the overall timeout to give us. So this would be helpful for testing, to be able to look at the JGA dashboard we mentioned earlier, to look at where your time is spent for your services and what is a reasonable number for your services to do retries and timeouts, because these numbers are important to get them right. And what's interesting here is, again, traditionally you would actually have to modify your application to add a loop to do multiple retries and to do timeouts. And with Istio network resources, you can easily configure all that within a resource and redeploy that resource. Kiosk testing, in this example, you don't expect everything to be go correctly all the time. So we are introduce some delays to 90 seconds delays in this example for the stock code services. So what if that service is really slow? How are we going to handle this? Outbound traffic, remember we talked about 104 service, stock code service needs to reach an external service to get the live stock price for the moment. So Istio does provide capabilities to allow you to control outbound traffic by default to allow users to easily onboarding traffic to Istio. We are allow any traffic to go outside. Certainly, mesh administrator probably doesn't want to do that. As the application gets onboarded to the mesh, as the team tighten up the security, they're going to precisely specify what other services can be allowed. So you can configure allow any to be registry only to tighten up that control, and then which would require you to declare these are the services I want to access. In this example, through a service entry resources, we are declaring, we're going to allow cloud.iexapi.com to access our services to access that particular host 443 port number. So the control outbound traffic is actually a very complicated topic. What we have been showing is a really simple way to control the outbound traffic. In order to really protect the outbound traffic, to make sure all the paths not going outside and only goes outside to this specific host, it's best recommended to use egress gateway and also apply network policies on top of egress gateway to ensure the services within the mesh only goes to the egress gateway, and the egress gateway would be the central point to access all the external services. So that would be a best recommended practice to secure the outbound traffic from both level 3 and also layer 7 level. Let's talk about debugging, because oftentimes we actually spend a lot of time debugging what might go wrong as part of onboarding the trade services into Istio. For example, in this case, in the gateway resources, I actually made a typo here, and what Istio provides is the analyze command to help you easily analyze what might be wrong. So you can do analyze a particular YAML file. You can even analyze a live cluster. In this case, it easily tell me, the simple, which I missed 2 characters, is wrong for the TLS mode. You can also inspect pod and services using the describe command. As in this example, it would tell me, whether I am named my service port, what other port number it's listening. So all that information is available to me instantly through this. You can also check your proxy configuration, make sure, it has the right route. Proxy configuration is a little bit complicated, but we do have a dedicated guide on how do you check your listener, how do you check your endpoint, and routes on Istio.io. You want to check your proxy status, so you want to make sure it's all synced. That basically means the status that IstioD knows about your proxy is same as what your proxy really is. So the configuration are distributed to your proxy sidecar. With that, I'm going to pass it over, stop sharing, and pass it over to Ram, who is actually going to show us something more exciting.
Great. Thanks, Lynn. I'm going to try to share my desktop. Are you able to click on my name and make me presenter?
Yes.
There we go. Perfect. Okay, so what I'm going to do is, or attempt to do, is just demonstrate all the concepts that Lynn just, talked about in great detail, but instead, show it from like an in-practice perspective. Okay, so first we'll start, kind of from scratch. Well, I'll pull up my cluster in the IBM Cloud Kubernetes service dashboard, and this is my cluster. This is a cluster with 4 nodes. They're in the Dow 10 data center. The first thing I'll do is I'll go to the add-ons page and install Istio. So currently, I don't have Istio installed in this cluster. So I'll click install, and then it does a verification to see if my cluster is okay, and if it is, the install should now proceed in a few seconds. So while that's going on, let's launch the Kubernetes dashboard. As you might know, there's 2 ways to interact with Kubernetes. There's the kubectl or kubectl CLI, and then the Kubernetes dashboard. Different users, depending on how skilled you are comfortable with one versus the other. So in this Kubernetes cluster, one thing I've already done is deploy that stock trader application. So if we pull up the slides again real quick and take a look at what the stock trader application looks like from an architecture perspective, there's a trader service, which is kind of like your UI. It talks to a backend portfolio, it talks to another backend, and then talks to an external API. And then in a different namespace, there's the DBT service. So if we look at those in the Kubernetes dashboard, you'll see the same thing. If I switch to the stock trader namespace and scroll down, you'll see the trader, stop quote, and the portfolio deployments. And then if I go to services, if you're not familiar with the service is a way in Kubernetes for you to expose a particular deployment either internally in the cluster for other deployments to consume or externally. So right now, all 3 services are just deployed as internal cluster IP services. So there's no ingress from outbound, from internet traffic coming into this yet. So I have 3 deployments and matching 3 services. And I'll show you the same view from my CLI. So you have kubectl get pods. And this is pointed to that same cluster. And you can see I have those 3 pods showing. And there's 1 out of 1 for each. That means there's only 1 container in each of those pods, as you would normally expect in Kubernetes. So we just installed Istio not long ago, a few minutes ago. So let's take a look to see if it got installed properly. Istio, the control plane of Istio is usually installed in the Istio system namespace. So kubectl get pods services /n Istio system. Okay, there we go. It looks like the installation is going well. So you can see a bunch of these pods are just coming up about 84 seconds ago. So this is the one we just installed. Taking a look at these pods, this is Istio 1.4. Lynn talked about Istio 1.5. I'm showing Istio 1.4 right now because Istio at this point is 1.4. Red Hat OpenShift Service Mesh 1.1 is also built on Istio 1.4. So they talk about Istio 1.5, I'm showing 1.4, they're pretty equivalent. Except for the big difference in looking at pods is that in Istio 1.5, you have that one Istio D monolith, which encompasses a few of these different pods together. So if you look at these, there's a Grafana port, which is like a monitoring dashboard, Citadel to manage the Istio security, like cert rotation, ingress and egress gateways over here. Ingress gateway is for managing your incoming traffic. Egress gateway for managing your outgoing traffic. The Istio Galley component is responsible for validating your Kubernetes YAML that you write for Istio Galley component, make sure that everything is good before applying it. A pilot is like the main brain of Istio control plane. It is responsible for taking that configuration from Galley, it'll convert it to Envoy config, and push it to each one of the sidecars so that every sidecar gets what config it needs. Istio policy is a component that is going to be deprecated soon. It's the policy management component. We're going to talk about this in a little while, how this policy is being moved from mixer policy to the sidecars themselves. So let's put a pin on that. The sidecar injector is responsible for automatically or manually injecting the proxy to run next to your container in the same pod. So as Lynn said before, with Istio, when you add your pods to the mesh, in one pod you have your application container, and then another small container that runs next to your container, and that container is the Envoy proxy container. And this injector is what is responsible for injecting that proxy so that you're not having to manually, write out the deployment for each one of those proxies. And then there's a few telemetry and tracing pods, and KLE and Prometheus for more telemetry information. The Istio Ingress Gateway component is actually like a load balancer, right? It manages incoming traffic, so it's exposed with an IP address. So this IP address is going to be important because that's how you enter into your mesh, because that's the main ingress into your Istio system, into your Istio control plane. Okay, so now if we do like kubectl git pods -n Istio system again, you should see that everything got installed. Okay, perfect. There's also the istioctl command line interface. So if I do istioctl version, it will check the version of the istioctl client that's running locally, as well as the control plane version that you have deployed to the Kubernetes cluster that it's currently pointed to. So it says the client that I'm using is 144 and the control plane is 148. And then I have a few pods that are also deployed that are also 148. Great. So now let's go back to looking at the pods for my stock trader application. kubectl get pods. So these pods are not part of the mesh yet, right? So I've installed Istio, but my existing deployments and pods don't know anything about it. Istio is running in its own namespace. I need to add these pods, to the mesh. Lynn talked about various strategies on how to adopt Istio. You can add these pods to the mesh, or what's actually more common and more easy is just do the ingress first. So you're just managing the incoming traffic first. So the traffic comes through the Istio Ingress Gateway, and then we can route the traffic from the Ingress Gateway to these existing pods. So my pods itself are not part of the mesh, but I can still take care of the Istio Ingress Gateway for the observability and control aspect of it. So in order to do that, I need to define two resources, the Istio Gateway resource and the Istio Virtual Service resource. So first, let's take a look at the Istio Gateway resource. Trader Gateway. So Trader is my UI service. So that's going to be the one that's going to be receiving external traffic. So that's what I need to expose. The Istio Gateway resource looks like this. I think of Gateway as like your main gate or entrance or your border gate into your mesh. It's where you declare what host you want to listen on and what port you want to listen on. So in this case, I'm listening on all hosts, but if I was running this on stocktrader.com, then I would probably put stocktrader.com here so that it only listens on that particular host. You can also declare ports, so I'm listening on port 80. If I want to do SSL, I would be listening on 443. But there's no routing rules here. This is just kind of like defining your entrance, right? But once you get into the entrance, where does traffic go? That's a virtual service. Now, if I pull up the Trader virtual service, so this virtual service is saying that it's going to get bound to that gateway. So that gateway I showed a few minutes ago or a few seconds ago, it's going to bound to that gateway And anytime that there is a header match for /trader, so this is stocktrader.com/trader, if it does a match for that, then it's going to route that traffic to my trader service on port 9080. So simple enough. So let's go ahead and apply both of them. kubectl apply-f, then we'll do trader gateway, and then we'll also apply trader, the virtual service that I just showed. Okay, so now I have gateway and virtual service. So now I can access my application by going to that Istio Ingress gateway. So if I do kubectl get service-n Istio system, I want to find the IP address of my Istio Ingress gateway, which is over here. So I'll copy that, and then go to my browser and type trader, and you can see it routed directly to my trader UI application. So simple enough. My pods are not part of the mesh yet. I'm just taking advantage of the Istio Ingress gateway to route traffic to my existing pod. Now, if you didn't have Istio, you might have used a Kubernetes ingress object or like an OpenShift route object. So with Istio, you're not using those. You're using Istio Ingress gateway, using a gateway and a virtual system resource. Okay, next thing we want to do is start adding my pods to the mesh, one by one incrementally, because your pods might not be compatible with Istio. You might have to make small changes to the configuration file. So it's usually not a good idea to just enable Istio for all namespaces and just add all your pods, because if things break, you don't know what pod it was that's broken. So it's more common to add one pod at a time. So we'll use the Istio CTL add to mesh command, add to mesh, and then we'll add the service, the trader service. So I'm specifying that I only want the trader service added to the mesh. So what this will do is it will find the deployment that's associated with this trader service, and then it will inject the sidecar for just that one deployment. So let's take a look at this. Let's jump back to the Kubernetes dashboard and then refresh this, and then we'll kind of figure out what it did. So here's the trader service. The trader service is referring to the deployment of this trader. And now from the deployment, I would go to the replica set. And now this is all Kubernetes stuff. And then from the replica set, I'll go to the pod. And now in the pod, if you scroll down and look at the container section, I have my trader container, which is as expected, but I also have the Istio proxy container. So this is the container that it injected for me. You should also see an Istio init container. This is like an initialization container, which does the IP tables rerouting. The way the proxy works is it intercepts all inbound and outbound traffic, and that's done through IP tables. So this is just a container that runs that IP tables command, and then it creates this proxy. So that's the dashboard view. And now if I go back and do kubectl get pods again, you'll see that the trader pod has 2 out of 2. So that means there's 2 containers running in it. As I just showed you, and one of them is the original trader container, and then another container for the Istio proxy. So now I have one pod as part of the mesh, and it seems like it's working okay. So if I go back and send traffic to it, I can still send traffic to it. So nothing's wrong with this pod. I just added this pod to the mesh. So you would incrementally go add to mesh one by one. Now, when you're comfortable and you tested everything, you will want to enable automatic sidecar injection for all pods that get created in this namespace. So I'm currently, in the stock trader namespace, and let's say that I'm ready to go all in on Istio. I know it works for all my pods, so I just want to enable it for that namespace. And the way I would do that is I would label that namespace. The labeling command is kubectl label namespace trader, and then I want to label it with Istio injection equals enable. So now I've labeled the namespace. Now going back to Kubernetes, the Kubernetes dashboard, if I list the namespaces for the stock trader, you can see that it has this new label that I just picked up. So now anytime I deploy anything into here, it will get the sidecar injected automatically. I don't have to do the add to mesh anymore. So if you're adding like kubectl apply-f, like trader deploy again, this would automatically pick up the sidecar. But I also have a bunch of other pods in there, and I don't want to deploy every single one of them again. So I'll just do a hack and I'll just delete all the pods. Now, when I delete all the pods, the way Kubernetes works, if you delete a pod, it's going to create another pod to take up for its place, because you have a deployment object that is telling Kubernetes that you need to have X number of pods for that resource. So if I delete the pod, it's going to stand up another pod. But because this time I have the namespace labeled with automatic injection, it's going to inject the Istio sidecar to all my pods, the new pods that get created. So now if I do Istio get pods, you can see that I have 1 out of 2, 1 out of 2, 1 out of 2. Things are coming up. Soon I should see 2 out of 2. There we go. It's like things are settling down. Because I already have one trader pod, this Kubernetes is cleaning up my other older trader pod. All done. So all 3 of my pods are now part of the mesh. One cool command I want to show is the Istio describe command. So instead of looking up what virtual services are applied to a pod, what is the ingress gateway IP address, like all of those are manual tasks. This is kind of like a shortcut. I can just do Istio describe, and then I can describe a service, creator service. And then this is really nice because it shows me that this particular trader service is exposed on this ingress gateway IP address. It's listening to this, these routes /trader. I have a virtual service applied. I have, permissive mutual TLS enabled. The container, the service is exposed on port 9080, 9443. So this is a great debugging tool, right? Anytime you are trying to figure out, why something's not working, I usually just describe that service and see if everything looks good. So now if I, send traffic to this again, oops. Things still continue to work, as expected. So we've added all pods to the mesh. So next, let's do some cool, interesting Istio stuff, right? One of the most interesting features is to be able to do different versions and send a subset of traffic to that version. So I've shown you like this is version 1 of the trader service. Let's deploy another version of the UI, the trader service. So kubectl apply -f, and then trader deploy v2. Okay. So I'll apply that, and while that's being applied, I'll show you what v2 looks like. v2 is pretty much the same as v1, except if I can find the image. In the image, I've changed it to a different image, right? I'm not using version 1 image, I'm using a different version of the image. So maybe this has a bug that's fixed. In this case, I rewrote the UI to be a little bit more modern. Keep in mind that the stock trader application, we purposely chose a really old kind of 2000s application just to show you how you can modernize an application and still use Istio with it without having to do any code changes. This is a Java application that was written, like maybe 10, 15 years ago. So let's say I have like a new UI version of it that I deployed. So now I do kubectl get pods, and you can see I have the trader as well as trader version 2. But I didn't create any any routing rules to it. So Istio is not going to know which version to send this traffic to. So if I go to my browser and refresh, like sometimes I'm getting the new version. This is version 2 with the different header. And then if I hit refresh again, it's the version 1. So it's almost random, right? So well, we definitely don't want that. We want to control who gets what. So as Lynn talked about before, the way to do that would be a virtual service. Let's pull up our editor, and we'll apply a virtual service that says that if my user agent, so it's checking for headers, and in the headers, if there's a user agent header and it has the word Firefox regularity expressions matched to it, then we're going to send that traffic to version 2. And then everyone else gets version 1. So this is a good way to load balance your traffic based on the browser. But Istio doesn't know which one's version 1 and which one's version 2. And the way to tell Istio what that is called a subset. So if I go to, and the way to define a subset are destination rules. So if I go to Trader destination rule, this is where I'm telling Istio, hey, I want to name my subset version 1, and every pod that has the label version v1 is going to be called version 1, and every pod that's version v2 is going to be called v2. This is a simple labeling, but most of you might have your containers labeled something like 3.6. Whatever your version numbers are, right? But with Istio, if you just want to give it an easy, simple alias like version 1, version 2, then this is how you do it. And this label would map, if you go to your deployment object, like the labels are right here. Right? This is the label that it's looking. Let's put that back, version 1, version 2. So again, I'll apply the destination rule, and then the browser virtual service, right? So I always like to do a describe just to see if my configuration that I applied looks good. So now it's showing that I have 2 matching subsets, version 1, version 2, and I have the 2 routes. Now if I go back to Firefox and if I hit refresh, you can see I'm always getting the new version 2. But if I launch the same URL in Chrome, I'm getting version 1. So this is working as expected. Let's go back and play around with some other virtual services. We've also shown like percentage based. So in this example, is showing that version 1, 80% of the traffic will go to version 1, and then 20% of the traffic will go to version 2. I don't think I'm going to apply this and show you because you get the gist of it. But what I do want to show you is if I have any typos in here. So let's say that I have 80% here and then 20% here, but I accidentally have a typo and I put 200%, right? So that's when the Istio analyze command comes in. So I can do Istio ctl analyze and then point it at this virtual service. And it gives me the errors. See the percentage 200 not in range of 0 to 100. So that's nice. This is a great way, if you're using CI/CD to apply, YAML, you want analyze is a good way to make sure everything's good. So even if I fix it, and let's say you're like referring to a service that doesn't exist. So let's say trader service, and I accidentally put another public key at the end. If I do the analyze command again, so this is actually looking to see in Kubernetes, in my Kubernetes cluster, do I have a service called trader-service EEE? So it's checking to see my Kubernetes API to see if it's actually valid before it applies. So very powerful command. So once I fix that and do an analyze again, you can see I have like no validation issues. Okay, let's see what else. Oh, security. Definitely need to talk about security. So in 1.4, when one pod is talking to another pod, by default, it doesn't use mutual TLS. One of the benefits of Istio is that the proxy that runs next to your container can automatically upgrade the connection to mutual TLS, and then it'll talk to the proxy on the receiving side, and that proxy will decrypt that traffic and then send it over to your pod. So your containers don't know that it's using mutual TLS talking to one another because the proxies that are sitting in between are doing all of this encryption magic. So in Istio 1.4, you actually have to tell Istio that, hey, I want my pod to have mutual TLS when talking to it. And that is done using a destination rule. So this destination rule is saying that all hosts start out local. So like all hosts start out local would be, so in Kubernetes, your services are defined as like service, your name of your service .fcc or like your namespace.fcc.cluster.local. So it's just doing a match that says all local services, when you're talking to any of my local services, you need to talk to Istio neutral. You need to use Istio neutral. You can also, specify in here that, like if you only want the trader service to be communicated to with Istio mutual TLS, then you can specify. Or you can just specify, start out local, then Q Istio -f and TLS. And that should be it. Like you don't have to do anything else in your application for you to take advantage of SSL when talking to one pod to another. So now if I hit refresh, everything is still working fine. I can still log into my application and everything works normally. But Istio is the one that's doing, encryption, talking to one another automatically. Okay. In Istio 1.5, this destination rule is not required because it uses automatic mutual TLS. So Istio will automatically try to determine if it can do mutual TLS between a pod to pod, then it'll just go ahead and try to do it for you automatically. But you can do a destination rule to, if you don't want that behavior, then you can just remove the TLS mode so that you don't get to mutual TLS. Okay, so now that we've added all of our pods to the mesh, we're going through the ingress gateway to talk to our services. Let's take a look at some of the observability dashboards that you get. For that, first I want to send some traffic to my application, like send some load. So I created this Apache JMeter script to basically log in, add portfolio, do some tasks for me so that it generates a bunch of load to my application. So that's going on right now. And while that's going on, I'll launch a few dashboards so we can take a look. First dashboard I'll launch is Kiali. To log into Kiali, you need to specify a secret on what your credentials is going to be. I created a secret for that, so let's apply the secret. And this just is specifying what my username and password for Kiali is going to be. And then once it's applied, then I will do istioctl dashboard Kiali. And I'll launch my Kiali dashboard. Looks like, let me try it again. I think it didn't take the secret fast enough. Come on, Kiali. It's still saying the secret is missing. Oh, just took it a few seconds. Okay, so now I'll log into my Istio dashboard, and I can see all those. If I go to Graph and then select the namespace where my application is, you can start seeing the traffic that's going in. So I'll enable edge labels, display, traffic animation. And see, I didn't do anything to graph this myself. Kiali determined automatically that this is how my applications look like, right? So I have the trader service with version 1 and version 2. They're both talking to the portfolio service. and I can do additional stuff. The ICQLE is like main Istio dashboard. You can actually check out Istio config. It looks like I have an error in one of my gateway resources. So I can modify config directly in here. It's telling me something is not best practice. I can adjust virtual services, etc. So definitely a good tool. Or some of the other dashboards, I will launch the Istio Grafana dashboard. And Grafana is good for you to inspect like one service at a time to see how one service is doing. So with Grafana, I go in here, I can launch the Istio service dashboard, and it generates these custom dashboards for every one of your services that are part of the mesh. So here's the portfolio service, and you can see all the traffic that's coming in, how many error codes that I'm getting, how successful everything is doing. I can do one to the trader service. It's a good way for service owners to see how their service is doing. And again, these dashboards are created for you automatically. There's other dashboards. So if you want to just check out how Istio itself is doing, there's the Istio performance dashboard where you can keep track of the CPU usage, the memory usage, etc. Same way, there's the Istio Jaeger dashboard. It's very simple to quickly launch all these dashboards and then see how everything is doing. I currently don't have any traces right now because, as Lynn mentioned before, I need to set the trace span to more than 1% for it to actually capture traffic, and I haven't done that yet. But this shows you how quickly you can launch it. All right. I think that was a good overview of all the Istio features that you would probably experience in the first few days of adding Istio to your workload, launching the various dashboards, incrementally adding pods to the mesh, enabling namespace-wide injection. Yeah, so I think with that, I'll hand it over back to you, Lynn.
Hey, Ram, can you hear me?
Yes, I can hear you.
Sorry, I was talking on mute. That was a really, really good demo. Do you want to do the rest of the slides, or you could?
Oh, sure. Yeah. Great. I think we left off in. Yeah, right here. Okay. So now let's go back and talk about how the community is doing. What are some of the major features that we released recently, what we focused on, and what's coming up in the roadmap. When Istio 1.0 went out, that's when we declared that, all right, Istio is production ready for our users, right? So this is when a lot of clients are like, okay, I'm going to go and try to adopt this in my workloads. And we got a ton of feedback, right? Mostly due to scale, right? People were deploying it on massive workloads and hitting bugs in Istio that, honestly, we didn't imagine. That was back in 2018. We were so focused on features that we didn't realize that, the scaling component of it and the performance component of it, everyone has different requirements. So we put it out there. People tested it. They gave us a ton of feedback. They loved a bunch of things about it. There's things that need to improve. So between 1.0 and 1.1, we really focused on the enterprise users and to give them the scalability features, right? When you deploy it to thousands of services, is Istio control plane scaling okay? And as you can see, that took a very long time for us to do because we wanted to get that done. So Istio 1.0 we said was production ready, but Istio 1.1 is when we're going to say is enterprise production ready, right? They have different requirements of scale. So that was Istio 1.1 back in February 2019. And since then, we've committed to a cadence, right? We want to say that we will try to put out a new release, every around 2 to 4 months so that vendors, integrators, partners can rely on Istio releases to know when it's coming, et cetera. So this is when providers like IBM are providing managed Istio, providers like Red Hat are providing service mesh that are all built on top of Istio. So for them, this release cadence is important for them to rely on. Since then, we focused on performance of one release, and Istio 1.3 really focused on usability. We've kind of doubled down on usability in 1.4, and then in 1.5, we've made major simplifications for the architecture. Some of the features that we want to highlight for 1.5. 1.5 recently was released, so let's talk about what are the big changes. Simplified architecture. As I've shown you in my Istio CTL control plane pods, when I did Istio kubectl get pods, I had all of those pods. Well, we built Istio using microservices, but then we realized that all of those pods are built using the same language. So it's not like you have language flexibility. They're all deployed together. They're all upgraded together. So we're not really taking advantage of them being microservices. We're just absorbing the overhead of managing different life cycles. So let's just go back to monolith. And so that's what Istio D is, right? It is a grouping of all of the Istio components so that it's hidden away from our end users, and it helps us service it better. So with the big change you'll see is the stuff on the bottom, the control plane. In Istio 1.4 on the bottom left, you have all those separate components. And bottom right, in Istio 1.5, you just have one component. Now the features that they deliver is the same. It's just kind of grouped together. So less things to go wrong, less pods, more performance, all better. Another big bottleneck in Istio has been the mixer policy component. The mixer policy component used to be the separate component that each one of the proxies would have had to ask, hey, is this request, is this communication allowed? And then the proxy component would go check to see if that's allowed and come back and say yes or no. Now you can cache the response, but it still wasn't ideal. And this was one of the things that we've learned between 1.0 and 1.1 that, man, this is kind of our main bottleneck, and we have to fix this. So with Istio 1.5 is when we took a major step towards that direction by adopting WebAssembly. WebAssembly is, think of it as like a binary artifact that you can inject directly into the Envoy proxy itself so that it can do its own policy checks and not have to rely on another component and do this extra network hop. So that's what WASM is. It removes that single point of failure, that mixer component, because every proxy can do its own policy check now. It greatly improves performance and makes the architecture much more simple. It also allows for greater extensibility because developers can write these WASM WebAssembly binary artifacts in various languages and package it up into this one binary, and then use something like Solo's WebAssembly Hub to share it with the world, and then people can consume it and add it to their Istio Envoy. Secret Discovery Service is another big improvement in 1.5. Previously, the certificates that the proxy used for communication would be file mounted, and that caused, it's like a slight, security concern for these certs to be file mounted. Whenever the certs had to be updated, there was a little bit of downtime as you needed to update, restart Envoy. But Secret Discovery Service basically is a way for Istio control plane to pass in the new certs, directly over the wire, and then the certs stay in memory, and then Envoy is hot restarted, so that there's no downtime. It's more secure. And then it works better with Kubernetes pod security. It also allows you to pass certificates to your ingress gateway in a much more easier and expected way, especially if you have multiple hosts coming into your ingress gateway. Some performance Istio by the numbers. This is something that we get asked all the time, right? What is the performance impact of adding Istio to my workload? I think these numbers are actually old. Instead, we know what I'll do is I'll just launch this URL so we can get the truth straight from the source. Here's the performance summary for Istio 1.5.2. So the Istio load test, we load test with 1,000 services and 2,000 sidecars. So think of that as like 2 sidecars, 2 replicas, right, per service, or 2 pods per service. And then we send 70,000 requests per second through the mesh and then see what the performance impact is. And we do that without Istio, with Istio, Istio with Mixer, and Istio without Mixer policy, et cetera, various combinations for you to see what the output is. So by default, if you have Istio installed with mutual TLS turned on, each one of those Envoy proxies uses half a virtual CPU and 50 megabytes of memory per 1,000 requests that are going through the proxy. I think this last line is the most important one, is what is the latency that the proxy adds? So the proxy on each side would add 2.8 milliseconds of latency. So that's that extra hop going through the proxy, the interception. With this big of a mesh, the Istio pilot component will consume 1 virtual CPU and 1.5 gigabytes of memory. And then the telemetry services, if you're using them, uses 0.6 virtual CPU per 1,000 requests per second that are going through the mesh. You can read more detail on this page, but really, like, Istio performance depends on your workload. Some people have said that adding Istio has made their performance better than before because they were using old JVM code to do neutral TLS or encryption directly in their applications. And now that with Istio is doing it for you, they rip that code out of their application, and Envoy can do encryption much faster than their Java code was doing, for example. So it really depends, the number of services that you have. Are you using like different namespaces for isolation? How do you have your resources configured? Do you have mutual TLS turned on? How many policies do you have? Things like that. But I think this last line, Envoy proxy adding 2.8 milliseconds, that's a good number to start your Istio evaluation. Okay, let's see. Going to what's on the roadmap. We're probably going to invest a lot more on WebAssembly, right? The WebAssembly stuff is kind of new. So all of the old Mixer policies would have to be migrated over to WebAssembly extensions. So creating the tooling, the SDK, and the documentation for developers and vendors to build those Istio policy extensions is going to be a big focus. We've greatly simplified the Istio installation. In the past, there used to be multiple ways for you to install Istio, like true Helm chart, Helm template, Istio TTL, et cetera. So we're kind of merging all these different Istio installation knobs, et cetera, into a single API called the Istio Operator API, and then building the tooling kind of on top of that single source of truth. With the Istio Operator API, you can define your Istio mesh configuration in one YAML file, and then use Istio CTL to point to that and say, hey, install Istio for me that matches this. Or you can use an Istio operator that runs inside of your Kubernetes cluster to read that config. You apply the Istio operator config directly to Kubernetes, and the operator will read it, and then keep making it happen. So it's like a live update of your Istio mesh. Multiple control planes, being able to deploy multiple Istio control planes per cluster, whether that's for multi-tenancy or if you're doing version installation, version upgrades, so you want to make sure that the one control plane is active while the new control plane version is coming up, and then you send traffic to the new one. And then hardening the multi-cluster, multi-mesh scenario. So far, most of the Istio documentation kind of focuses on a single cluster and then a single mesh inside of it. We're getting a lot of requests from the community that they have their workloads deployed across multiple clusters, and they need a way to send traffic from one cluster to another cluster, but still be part of the same mesh, or federate 2 meshes together. So various patterns that are being developed to make this happen. Keep in mind that these patterns exist currently, like they work, and that you can go set up an Istio, these various multi-cluster patterns with Istio right now, but it takes a lot of manual effort and maintenance. So the work that's going on right now is to abstract away some of the complexity so that it's much easier for you to maintain. There's the single control plane approach where you have the Istio control plane installed only on one main cluster, and then you add a bunch of clusters to it, but those clusters only have like a small subset Istio, like an Istio remote component that runs, but your main control plane is still in one cluster. So that's kind of like, it's good when you have that single administrative control and you just want to add additional clusters to the mesh. You can still achieve HA by adding multiple instances of this control plane, but there's still one main mesh that gets expanded. There's a multiple control plane approach, where so if you have multiple clusters, you deploy a control plane across all of them, but they all use the same root of trust. So you're basically creating one large mesh across multiple clusters, but they each have their own control planes. There is federation concept, so that you can have two different Istio meshes, but just the gateways, the ingress and egress gateways establish a secure trust between one another so that you can route traffic from one to another. The multi-cluster and multi-mesh concepts are pretty advanced right now. There's more simplification that needs to be done for a general consumer to absorb it, and most of the complexity comes from the fact that everyone has different requirements for multi-cluster, multi-mesh. Some people have clusters that are on different networks, so they don't have a flat network. Some people have clusters that are on different zones, so they're using multiple clusters for like active-active or active-passive, or multiple clusters just to have a larger cluster and have failover scenarios. So based on what your requirement is, the Istio mesh requirements greatly changes. So the community is working through trying to figure out, what is the best way that satisfies the greatest set of audience. Like I've said before, the Red Hat OpenShift 4.3 comes with Red Hat OpenShift Service Mesh and Istio in the Operator Hub. And that is based on Istio 1.4, but and the way the installation works over there is pretty simple. You launch your OpenShift 4.3 cluster, you go to Operator Hub, you install the required operators, and then you install the Istio OpenShift operator. Some of the key differences between OpenShift Service Mesh and Community Istio. OpenShift Service Mesh out of the box is set up to work well with multi-tenant control plane scenario. So you can have different OpenShift projects be part of, act kind of independently and have its own mesh. There's no cluster-wide installation like with normal is Community Istio, where you just have this one Istio system control plane, and then that's meant to be used for all of the projects in the cluster. With OpenShift Service Mesh, you don't have like the namespace-wide automatic sidecar injection. You have to modify your deployment per pod and specify this annotation on the pod to say that I want the Istio sidecar added to my deployment. A few other differences: OpenShift Service Mesh uses OpenSSL instead of boring SSL. And to get past the tighter security restrictions that OpenShift has with the init container, it uses the Istio CNI plugin to not require the Istio init container and configuring that IP. So I believe that concludes our /deep dive overview and demo of Istio. I hope we did a good job covering all the various aspects of Istio. I know Istio has a lot of features, but we've really focused in the last year or so to make the most needed features as easy to consume as possible. And those are done, through like the Istio CTL, add to mesh, describe, analyze command to make, even though it's very powerful, most of the features that people use let's get those in a very simple and user experience focused way. So we hope you try to add Istio to your workload, to Kubernetes or OpenShift, and if you have any problems, reach out to us. We're very active in the community. We're very active inside IBM, so we're here for you to adopt Istio Service Mesh to your workload. So with that, I think we'll open it up for any questions.
Yeah, hi, this is Len. I believe, Michael, you had a question. Can you please address API management with Istio user cases? That's a really interesting question. So in the early days of Istio, we actually had an API management workgroup within Istio, and we had a few rounds of workgroup discussions. And then later on, the community actually decided to end that workgroup because as a community, we kind of decide, API management and Istio, they are complement to each other. While API management does provide a lot of functionality that Istio doesn't provide. For example, API management allows users to generate API documentation, manage access and usage policies on these API, to be able to do billing, consumption of the API. So I think it's an interesting model to kind of having them complement each other, depends on your requirements. Because there's clear certain functions of API management are not provided by Istio.
Right. I mean, I think I would say that Istio would allow API providers, like the developers who are creating the APIs, to define the APIs, to provide client identity and enforce policies, telemetry, etc. But the API management vendors would then build their value on top of this, right? So they'll focus on grouping and publishing APIs to a set of audience, how you do monetization, how do you create developer portals, data format, translation, and then the management of user identities, integrating it with existing user LDAP providers. So all of those would sit on top of Istio, and whereas Istio would focus on the API to allow developers to do it. So they're definitely complementary features, and Istio wants to work with API management providers to build that integration.
Yeah, with that, we would like to open the session to you guys. If you have any questions. And I think you could raise your hand, then we should be able to unmute you. And I wasn't sure if you can unmute yourself, but if you raise your hand, we will definitely make sure you're unmuted. And if you guys are interested in running through the steps that Ram are showing, we do have the book mentioned. So if you Google search Istio Explained book, you will actually find the book pretty quickly. I think it's one of the first few returns. And then through the book, there's the GitHub URL where you can follow along to set up the guiding example to be able to inject your services to the mesh. So everything that's been shown here, you will be able to follow along by reading the Istio Explained book. By the way, the book is free. You can get the digital copy by a simple registration.
And I have just posted the link for registration here in chat. And please feel free to download. It's a very simple process and it's a great book. Any other questions? And if you have any questions, please feel free to raise your hand. I was able, and muting all is going to be a bad idea because there's a lot of static on the line. Mark, do you have a question? No, it's very static. And Ram, anything you'd like to add to the sessions before we wrap up for today?
Yeah, I guess I would just say, you guys have myself and Ram's contact. You can feel free to reach us at Twitter. Some of you are asking the slides and recording, so we will definitely get those out to you. So you should be able to get the slides off the Think website along with the recording. So feel free to let us know if you have any questions.
There's also a comment from Nishant. Nishant, I'm going to try to unmute you to see if you would like to bring up your questions. Nishant?
Hi guys, can you guys hear me?
Yes,
yep.
We can.
Okay, so if you could go back to the slide where it's a multiple control plane in multi-cluster environment, which was just shown.
This one?
Yes. So in this one, how the two control planes are they getting synced with each other, or they are just living within that particular cluster itself?
They're not getting synced. In this example, both the control planes are independent, and it's up to the user to create any replicated configuration that they would need across the two.
Yeah, so I would say that
Gotcha.
that depends on your configuration. If you're using the replicate control plane model in Istio.io, I assume you are probably pretty familiar with Istio to ask that question. And then Ram is right, they are not synced. If you're using the shell control plane model, in the Istio.io, there is a possible way, which we haven't provided documentation to our user. You could potentially run the control plane on the cluster east in this diagram, and then you could potentially do API server peering between the two clusters to automatically discover endpoints among the clusters. So we do have a way to allow a user allow the cluster admin to do endpoint discovery across the two clusters. And then you would, as a user of these clusters, they would be responsible, make sure any of the services that require cross routing, it would make sure, service B is deployed onto both of the clusters, just for make sure the DNS is registered in each of the cluster for cross-cluster routing.
Gotcha. Thank you.
Yeah. Any other questions? I think Anita, I think I saw Igor, I don't know, or Edgar that raised hand.
Yes. There we go.
Yeah, thank you.
Yes. I did. Just two questions, or two comments, rather. First of all, great presentation. Please don't miss track of questions. Interest is rather a reaction to the very clear and extensive presentation. If others are more organized, and as I thought,
We have
I had a hiccup time try join because the so you may want to pass this on to other. Yes. Yes. I will find workaround. And,
that's good feedback. We're sad to hear that, because
workaround
that might mean that a bunch of people that wanted to come weren't able to make it.
The recommended link that.
And thank you for letting us know. That has already been reported to Control Central, so that they are aware of the issue.
Yeah, I saw that.
Yeah, we really, really appreciate you take the time to provide.
That was sad, yeah.
Yeah.
Sure. I mean,
oh my God.
I tried for about 20 minutes to get in. And
thank you for attending. Really appreciate and providing feedback.
This additional site will even WR item.
Yeah, Anita, I think if there's no more questions, we can probably wrap.
So thank you. I would like to thank all the participants for joining us today and share your thoughts and have great discussions with our presenters, and also a big round of applause for Rem and also Len for being our presenters today, and it's great to have you all. And we look forward to seeing you at a future presentation.
Thank you for joining.
Okay.
A good rest of the conference.